Here we go, the last thing that we got to learn how to factor are our perfect square trinomials. Okay, the other day we did difference of squares. That was one of our special products that we did last chapter, and we factored it. We went back to where we started from last chapter. So we're going to do the same thing here, except now we're going to look at our perfect square trinomials. So if you remember from last chapter when we did our FOIL method, we had two different pairs of binomial squares, a plus b squared and a minus b squared. Right, and if I expanded these out, it's really, a plus b times a plus b and a minus b times a minus b. But remember our quick trick to get them to expanded form, right? We squared the first term, squared the second term, and then for the middle, we had to multiply the two terms and double it, right? So it ended up being a squared plus 2ab plus b squared, and the other one, it just changes the one sign to a minus sign. So hopefully we remember doing that back from last chapter, because if you don't remember doing that, it's going to be kind of tough to try to factor here, because we have to recognize when we have a perfect square trinomial in order to factor back to one of our binomial squares. Okay, so let's take a look here. It says determine whether each trinomial is a perfect square trinomial, right? Yes or no. If it is a perfect square, we're going to factor it. Okay, so I'm taking a look at this first one. 2y squared plus 12y plus 9. Well, in order to be a perfect square trinomial, I have to be able to square root the first and the last terms. And if I look at this, I can square root the 9. That would work. But I cannot square root this first term. So right off the bat, I know that it is not a perfect square trinomial. Okay, so I cannot factor it in the way that we're going to look at. I could see if I wanted to factor it by taking, 2 times 9, which is 18, and finding factors at 18 that add up to 12. But it doesn't say to do that. It just says determine whether it's a perfect square trinomial. And in this case, it's not. So I'm not even going to look to see if it's prime or if I can factor it. That's all I'm doing, just to see if it's a perfect square trinomial. Let's take a look at one that should work out to be a perfect square trinomial. Go to number 2. 25x squared minus 30x plus 9. Okay, so I take a look. Well, can I square root this first term? You bet I can. Can I square root this last term? Yes. So that's kind of my a squared and my b squared. So let's think about where this is going. So I want to see if I can get it into a binomial square, one of my square binomials. Well, if I take a look, what sign am I going to have, a plus or minus sign? I know it's got to be minus because of that minus 30x. Okay, if I look back at my first example, it's in this form, so I know it's got to be something, a minus b squared. That's what I'm looking for. Well, let's take a look. So, I'm guessing it's a minus sign. Well, if I took the square root of 25x squared, what would I get? I would get 5x. So that would be my first term. Well, if I took the square root of my last term, my square root of my 9, I would get 3. So 3. Well, I have to check and see if it works still. What do I have to check? I got to see if my two terms, when multiplied and doubled, equal that middle term. Well, if I multiply 5x times negative 3, 5x times negative 3, I get what? Negative 15x. And if I double that, I get negative 30x. So does it check out? You bet it does. So this would be my factored form. Okay, so I'm probably confused a few people there, so let's think about that. If I started with this, if I had that 5x minus 3 squared, remember going back to what we did, just what I was talking about in that first slide. Remember we'd square that first term, 25x squared, we'd square the second term and get a positive 9, and then we multiply the two for a negative 15x, and we double it for a negative 30x. That goes back to last chapter. So now I just took that, and I factored it. And if you take a look, to see if you can factor it or not, you just see if you can square root the first term, right? Because that's the a squared. See if you can get it to a, which I could. See if you can square root the last term. That's the b squared, which I could. I got it to 3. And then see if your combo, your two terms, your 5x and your negative 3, multiply and double to that middle term, which they did. So it worked. So 5x minus 3 squared. It worked out. Okay, let's keep looking here. Let's try another one. Okay, so that's my first thing. I'm going to see if it's a perfect square trinomial. Well, can I square root this first guy? Yes, I can. 7y. Can I square root the last one? Well, square root of 36? Sure, 6. Okay, so I'm going to check and see if I can write this as 7y. Well, now I'm looking plus because I got the plus sign right there. So plus 6 squared. Does this work? Well, I got to check. I got to multiply my two terms, 7y and 6, which give me 42y, and double it for 84y. Does that match up here? No, it doesn't. So I cannot factor to that. That does not work. This might be factorable, okay, but I'd have to do the a times c method and find factors of that add up to 42, and that's going to be a lot of work. It doesn't tell me to do that. It's just saying, is this a perfect square trinomial? Well, no, it is not. I was able to square root the first and last terms, so I got my a and my b, but I was unable to get the 2ab in the middle, because when I multiplied and doubled, I got 84y, and I was looking for 42y. So nope, I cannot factor that way. And taking a look at the last one, same process. Can I square root this first term? Sure, 3y. Can I square root the last term? Sure, 4. Well, now I got to test. Can I write it as 3y plus 4 squared? And I get the plus because of that sign. Well, let's multiply them. 3y times 4 is 12y, and double it for 24y. Does that match up? You bet it does. So there we go. Very good. So 3y plus 4 squared. Okay? So just checking to see if it's a perfect square trinomial. Well, we want to make sure we factor everything completely. Factor as far as we can go. So I kind of got 3 basic steps to be able to factor. My first step, always see if you can factor something out. Check to see if you can pull something out. See if you can factor out the GCF right away before you do anything else. That's my first advice, because that usually simplifies things. See if you can pull something out of there. Once I factor something out, or if I can't, that's okay. We go on to the next step, and we always check for a difference of squares, right? If it's in this form, a squared minus b squared. Or we check to see if it's a perfect square trinomial, which we were just doing, to see if it was a squared plus b, to see if it was a squared plus 2ab plus b squared, or with a minus sign. So I check for one of those two things. Always look to see if it's a difference of squares or if it's a perfect square trinomial. And if it is, I factor it. If not, I go to the last thing. You apply one of your factoring patterns, right? You look to see if it's a quadratic. Remember, if there's no coefficient on your second degree, or usually it's an x, could be a different variable, but your x squared, I can just jump right into my two binomials, right? If it has a coefficient, okay, then we got to take the a times c and go through that whole process of grouping, right? And anytime there's 4 or more terms, we always group anyway. Okay, so we're just applying every rule that we've learned right now. So a lot of stuff, but just go through these steps. Factor something out, check for difference of squares of perfect square trinomial, see if it's a quadratic to factor, just those different rules. So let's try some here. So factor if possible. The polynomial cannot be factored, write prime. So number 1, first thing I look for, see if I can pull something out. See if I can factor something out. Well, looks like I can factor out a 2, so I'm going to go ahead and do that. So divide each term by 2, so I'm left with x squared minus 16 in parentheses. All right, so next thing I look for is to see, do I have a difference of squares or a perfect square trinomial? Well, I have a difference of, are these squares? Can I square root both those? You bet I can. So I have a difference of squares. So I'm going to bring down my 2. And what does my difference of squares break up into? Remember, this has the 2 different signs, a plus and a minus. And I just square root each, right? So the square root of x squared is x. That's my first term. And the square root of 16 is 4. There we go. And don't just assume you're done. Always check. Okay, I got the 2 up front. That's okay. Can I factor this x plus 4? No. Can I factor this x minus 4? No. I'm done. There we go. So you always got to check. Never think you're finished until you know for sure. Number 2. Okay, first thing, can I factor anything out? Nope, I don't think so. Can't factor anything. Next thing I look for, is it a difference of squares or a perfect square trinomial? Nope, I can't take the square root of 12, right? So it's not a perfect square trinomial. So now I look, is it in one of my forms? Is it a quadratic? Yes, it is. Is it the easy way or the hard way? Oh, it's the hard way. I got a coefficient out here. So I got to take my 12 times negative 25, which gives me negative 300, and I need factors of negative 300 that add up to a positive 5. So I know one's a plus and one's a minus, right? Because they got to get to a negative 300. And if I start dividing negative 300 by some stuff, it ends up being what? 20 and 15. So which one's got to be positive? It looks like the 20 because I want a positive 5 out of that, right? And remember, when I do this method, I got to rewrite my quadratic with my two new factors. So I'm going to break up the middle term. So I rewrite 12x squared. And now instead, I'm going to put my negative first. I always like putting my minus first. Minus 15x plus 20x minus 25. Okay, now we go ahead and group. Anytime I got four terms, I group. Boom, boom, boom. What can I pull out of this first grouping? It looks like a 3x. And I'm left with 4x minus 5. So hopefully that's what I get when I factor out of this next one. And what can I factor out? Looks like a positive 4. And we're left with a 4x minus 5. That worked out nicely. So my product of my two binomials at the end would be 3x plus 4, the terms on the outside, and 4x minus 5, the one that matches up. Remember, don't assume that you're done. Check. Can I factor? No. Can I factor? No. Now I'm done. Good. And this last one. Well, four terms, I'm automatically thinking we better group. So I'm going to group these first two. I'm going to group these second two, but like I like to do, I don't like this negative to fool me, so I'm going to change it to adding the opposite right away. And now I'll go ahead and group. All right, what can I pull out of here? Looks like a 2a squared. So 2a squared, now I'm left with b squared minus, well, if I pull the whole thing out, we're really dividing. So you got 1, right? 2a squared divided by 2a squared. Okay. Well, I want what's inside of here to look like b squared minus 1. So I'm going to factor out a negative 2ab, it looks like. I'm going to factor out a negative 2ab. We'll see if it matches up. So now I'm left with b squared, because the 2's out, the a's out, and there's still a b squared left. And then I divide 2ab by 2ab, or negative 2ab, so that switches the sign, so it becomes minus, and we got a 1, right, because I divided the whole thing out. Boy, that worked out well, so let's rewrite this now. So we got 2a squared minus 2ab times b squared minus 1. Well, I got to look. Can I factor this? Well, let's take a look at this first one. Looks like I can pull something out of this, can I? I can pull out a 2a. Well, what's left? A minus b. Okay. What about this next one? Can I factor anything out of it? No. But I always got to check. Is it a difference of squares? You bet it is. I can take the square root of b squared and the square root of 1. So that's my two binomials with the different signs. So the square root of b squared is b, and the square root of 1 is 1. Boy, that's a big answer. I should still check. I can't factor anything in there, so there we go. There's my final answer. So that takes a little bit of work, right? You just got to keep going through. Follow those steps. Follow those steps I had in that last slide. Okay, we also might get something where we got to solve. Same old song and dance here. So I got a quadratic. So it looks like I want to get this guy equal to 0. So I'm going to add this 81 over to the other side. 81 over. So I got 4x squared plus 36x plus 81 equals 0. Can I factor anything out? Nope. Is it a difference of squares or a perfect square trinomial? It might be, right? I could take the square root of this and the square root of that, so I better check. Well, I'm looking to see if it's going to be something squared with a plus sign. So 4x squared, if I square out that 2x, that works. Square root of 81 is 9, good. Well, when I multiply those two and double it, I get 18x, double it for a 36x. So it checks out. So I know that this thing equals 0. Well, how do I solve for this now? I got to get x by itself. Well, x is inside the parentheses with that squared, right? So somehow I got to get rid of this square. Well, what's the inverse of squaring? Well, square rooting. Whatever I do to one side, do to the other. So it looks like I get 2x plus 9 equals, well, what do we get when we take the square root of 0? Just 0. Okay, and then I go through and finish solving. So subtract 9 from both sides, and we're left with 2x equals negative 9, and divide by 2. So it looks like x equals negative 9 over 2. Yeah. Good. What about this next one? It's already in factored form, isn't it? So I don't even need to worry about trying to factor, get it in equal to 0 or anything, because it's already factored. Well, how do I get rid of this square? I got to get rid of that so I can get the b by itself, just like we did in the last one. Square root it. Whatever you do to one side, do to the other. So I got b minus 7, right, because that cancels the square, equals, here's the tricky part. I know that, well, 6 times 6 is 36, right? But isn't negative 6 times negative 6 also 36? So this is really plus or minus 6. It's both of those, okay? Because it could be a positive 6 or a negative 6. So now when I solve for b and I add 7, what happens is I got two different situations. I got b is going to equal, well, this plus 6 plus 7, and b is also going to equal negative 6 plus 7. It equals both situations. So b ends up equaling what? 13 and 1. So you got to take the plus 6 plus 7, and you also got to take the minus 6 plus 7. So you have two answers there. So just be careful with that, right? Because I could plug 13 and 1 into my original equation for b, and it should work out. Okay, so we got a lot of information now into factoring, right? So just follow those steps. Go back those couple of slides ago. Follow those steps each time. You might have to keep thinking about your rules, but it just takes a little bit of time.